Hello everyone, this lecture video is going to be going over hypothesis testing for the mean where standard deviation is known. And just like with last chapter, when standard deviation is known, that means we're going to be using z-scores. So this is also known as a z-test. Now, we're going to use everything that we learned in the last lecture video and what's on this page right here, and then we're going to jump into an example because then we have everything under our belt that we need to do in order to perform a z-test or any type of hypothesis test. Well, before I can actually perform a hypothesis test, first I need to know how to find a z-score. For the situations we're going to be doing today, it's going to be z is equal to x bar, which is sample mean, minus the population mean. I'd highly suggest if you do not know those symbols already, you write that down. So sample mean, population mean, divided by the population standard deviation over the square root of n, which is the sample size. And what we're going to use later for when we're working with population proportions is we are going to use that p hat minus p, where p hat, okay, again, p hat is the sample proportion or sample success proportion, and then p is the population success proportion. Once we find that z-score, what we are going to do is we are going to compare it to our critical values. The end of the last lecture video was going through and finding critical values. For a left-tailed test, if our z is less than our critical value, I say negative a critical value, but when we're working with a left-tailed test, it's assumed to be negative. So when it's less than our z critical, we will reject H naught. Recall in the last lecture video, or maybe the one before that, I kept saying, keep in mind, what do we call these regions? We call them the rejection regions. Okay, well, if this is our rejection region and this is our cutoff value and our value for a left-tailed test is less than that, that means it's over here. It's in the rejection region. If it's in the rejection region, what are we going to do? We are going to reject. And then you just have to keep in mind, what are we always rejecting or fail to rejecting when we complete our test? The null hypothesis. Always the null hypothesis. And then we make a statement about whichever our claim was. For a right-tailed test, similarly, this is the rejection region. So if our z is bigger than the z critical, it's over here. So when z is bigger than z critical, right here, we reject H naught. And then for two-tailed, it's if it's less than or greater than whatever z critical value, we reject H naught. And so if it's over here or if it's over here, again, rejection regions means any z score in those regions, we are going to reject. And what are we going to reject? The H naught always. Cannot emphasize that enough. Always reject or fail to reject H naught. You know it's important. I would write it down. Okay, now let's use everything we've learned so far and actually perform a hypothesis test or a z-test. Let's jump into this example right here. A manufacturer claims that their allergy relief pills give, on average, full allergy relief for 24 hours. A sample of 25 people, notice what I'm highlighting when I'm going through this, keywords, just like we did in the last chapter, show that the average number of hours for allergy relief is 22. Again, average number of hours relief, 22. Assume that your population is normally distributed with a standard deviation of 1.97. Can you reject the manufacturer's claim at A equals 0.05? Now, no, right here, assume your population is normally distributed. Okay, that means we can assume we're working with a normal distribution. Again, that's the CLT. We're kind of using that in the background here. If our sample was bigger than 30, then we wouldn't need to use that. But either way, we're kind of just assuming that this is the case for most of our questions because this has to be the case, or else we don't know what to do. We can't perform a z-test if that's not the case, because recall, in all of these scenarios, we were working with a normal curve. So if I don't have a normal curve, then I don't know anything about the area and I don't know anything about the critical values. So, we need this to happen, and our question will tell us that what needs to be the case is the case. But that's all this question right here is saying. And then, can you reject the manufacturer's claim at A equals 0.05? Okay, A is really alpha. I just couldn't write alpha with my keyboard. Okay, so what is the question here? The question is, can you reject the manufacturer's claim? Which means we need to test the manufacturer's claim. Can I reject it? Well, I don't know. Let's test it. What is the manufacturer's claim? It's that the average is 24 hours. On average, get full allergy relief for 24 hours. Notice, no more than, no less than, just for 24 hours. So what's the claim is that for the population, it equals 24 hours. Well, the first step, and if you like to go about these in the case of here's what we need to get to, we need to compare our Z value to a critical value, and then using everything we learned. If you're a think through it person, that's great. If you're not, I would write down what I'm about to say. Our first step when it comes to performing a hypothesis test is to state the claim that we want to test. The second step is going to be to write down your null hypothesis and your alternative hypothesis, which to do so, we need to determine what our claim is. U equals 24. That includes equality. So recall from our first lecture video, that is a null hypothesis. So H naught is that U equals 24. That is our claim. What type of test are we working with then? A two-tailed test. We always have a null and alternative hypothesis. So what's the alternative to U equals 24? Well, what's the opposite of equals? Not equals. So the alternative hypothesis is that mu does not equal 24. Now, notice we said this was our claim, which means we're working with a two-tailed test. So let's draw a picture of our normal distribution. To be a two-tailed test means there are two rejection regions, one on the left and one on the right, each which has their cutoff critical values. Now, the last lecture video was us finding these critical values. What did we need to find the critical values? We needed alpha. Alpha, in this case, is 0.05. And so, for each individual rejection region, since total, alpha tells us area, alpha, we should think area. That tells us the area in total of our rejection regions. If we split that up into two equivalent regions, that gives us 0.025 area in each region. So how do I find the critical value? Well, I make a note. Well, the area to the left of our negative critical value is 0.0250. Now, why didn't I say this? Because if I have area to the left and a critical value, I should think, go to my chart. If you go to your chart, you will find the critical value that corresponds to 0.0250 is negative 1.96. And if you'll actually just give me one moment. Okay, so the negative critical value is negative 1.96, which makes the positive critical value positive 1.96. Now, let's look at what this previous section told us. It told us that if a test is two-tailed, then if the z-score for our situation, which we're about to compute, is less than this or greater than this, we reject H naught, i.e., if it's in these rejection regions, we are going to reject H naught. What I like to do after I draw this picture and find our critical values, which we do after we state our null and alternative hypothesis, is I like to go ahead and say that, okay, that means if z is less than negative 1.96, or greater than positive 1.96, it's in the rejection region. So we are going to reject H naught. I like to go ahead and write this. Now it's just a matter of what z is. We know what's going to decide whether we reject H naught or not. But what do I need to decide that? I need my z value. So let's see what the z value is for this situation. Well, to compute a z value, I need my sample mean minus my population mean, divided by my population standard deviation, divided by the square root of n. Typically, actually, as we go through this question, I'll write down, since it says a sample of 25 people, that means n is 25. And since it says the average number of our allergy relief for those 25 people is 22, that's our sample mean. So our sample mean is 22. And then down here, normally distributed, our population is normally distributed, and the population standard deviation is 1.97. So then I'll write that. And then we have all the parts we need. We just got to plug them in. So Z equals sample mean is 22 minus population mean is 24. You always use whatever value you used in the claim. Divided by population standard deviation, which is 1.97, divided by the square root of n, which is 25. If you go through and put that in your calculator, I'm going to take a second to do that myself. You will get negative 5.08 rounded. Now remember, we always round z-scores to how many decimal places? 2. If you do not automatically say 2, write that down somewhere. Write it on a note card and go and study and quiz yourself. Not study yourself, quiz yourself. Have on one side rounding decimals to round to for z-scores. And then on the back say 2. And have a friend quiz you. How many decimal places do you round for a z-score? And then you should say 2. Go through and do that. You have to know these things. You could round to more, but it's going to make your life easier if you know these things. So we get negative 5.08. Well, where does that lie in our normal distribution? It weighs way over here. Now, how do I know it's over here? Because negative 5.08 is less than negative 1.96, which means it's in our rejection region. So what are we going to do? We are going to reject H naught. That is the test, okay? So just to summarize, first state the claim. And as you're reading through the question, it's a good idea to go ahead and write down the properties you're finding. So your sample size, sample mean, population standard deviation, so on. Your second step is going to be to figure out your null hypothesis and your alternative hypothesis, stating which one's the claim and what that tells you about the type of test. Once you do that, you draw a picture of the type of test you're working with. And then you have to go and find the critical values for this test, which you find using your alpha. Once you do that, you write a general, what does that mean? Well, if RZ is in this critical region, so if it's less than 1.96, we reject, or if it's greater than that, we reject. Then, after you do all that, you go and find your z-score for the situation. The z is equal to this. Once you find that, you ask yourself, okay, is that in our rejection region? Is it less than negative 1.96? Is it more than 1.96? If the answer is yes, it is less than negative 1.96, then what do? Well, that means it's in the rejection region, so we reject H naught. What if it wasn't? What if it was in between the two? Then it's not in the rejection region, so we don't reject. Therefore, we say we failed to reject. We are actually going to see an example of each type of scenario that we may come across. I'm going to end the lecture video after we write our summation, our statistical hypothesis. Once we do that, I'm going to make a lecture video for the rest of them. But we just decided we reject H naught. But did we answer the question? What did the question want us to find? Usually the question's about the claim. Well, the question is about the claim. So I don't really care about H naught per se. I might if that's the claim, but if it's not, then I don't care about it. So I come up here and I say, okay, what was my claim? My claim was H naught. And my question was, can we reject the manufacturer's claim at A equals 0.05? The answer is yes. And what we say is we have enough evidence, or well, actually I keep using the second person, whatever that is. There is enough evidence at alpha equals 0.05 to reject the manufacturer's claim that on average allergy relief is 24 hours. For their medication, but we're just going to assume we know that's what we're talking about to save us some space in writing words. So your conclusions will always look like what I just wrote. There is enough evidence, blah, 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 at alpha equals to blah, 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 the whatever the claim was, okay? And so every single one of our answers should look like this guy. But everything else is us actually performing the hypothesis test. Okay, let's go over another example, but we're kind of, getting a little high on time, so I'm going to go create a part 2.